So let's now quickly go to Luxembourg, to Antwerp. And let's see the Notre Dame Spire. There you go. This is it. Flat Earth theory claims that a great example is the Notre Dame Antwerp Spire. Is standing at 403 feet high from the foot of the tower, with Strasbourg measuring 468 feet above sea level. Yes, this is it, the Cathedral of Our Lady, Antwerp. It says here actually that its height is 404 feet high. It's standing in Luxembourg, not Strasbourg, standing in Antwerp. Strasbourg. There's two Strasbourgs, one in France, one in Germany. This is in Antwerp. And as you can see from Google Earth, the elevation here is 4 meters high above sea level. 4, 6, 4 to 6 meters high. It's next to a river. And it's very close to the sea. Yeah. So you see, even here, their information is incorrect. It has nothing to do with Strasbourg. It's not 468 feet above sea level. It's only 4 meters above sea level. So anyway, I have a scale drawing of the Notre Dame Antwerp Spire at 424 feet in total, with its elevation above sea level. And I've placed it at 44.58 kilometers away from the common horizon of the lighthouse at Cape Charles. So you see, all these points now are joined by a common horizon. The lighthouse with the ship, with the horizon of the lighthouse, the horizon of the Antwerp Spire, the horizon of the ships. So you see, they have a common. Now they're at the correct distance and at the correct height to have a common line of sight to the horizon. So the ship at point B, since they can see the light coming from the lighthouse, they can also at the same time see the top of the spire at Notre Dame. That's 44.58 kilometers plus 15.74 kilometers for a total of 60 kilometers. That's the maximum distance that the Navy says the top of the spire can become visible. So at another 61 kilometers away and at a height of 810 feet, we'll have again a common horizon. At this elevation, at 810 feet, we can see the Notre Dame Spire. At this height and distance, we have the same horizon. Now the elevation here, the declination towards the horizon, would have to be a negative 0.23 degrees if light is straight, and if light is bending, it would have to be almost double that. This is according to Bowditch. If we continue further down, if we move 150 miles away from the Antwerp Spire, from this position, yes, if we had a ship sitting there at this height and distance, we have the same horizon. So if we have a ship at 150 miles away that can see the Antwerp Spire, then that ship would have to be sitting on the peak of a mountain at 8,221 feet. As we've seen up to now, the ship moving just 4.4 kilometers from C to B is greatly affected in terms of the light from the lighthouse, in that it drops from 90 feet down to 55 feet. That's a drop of 35 feet. So moving away from point C, moving backwards, you can imagine that just moving a few kilometers backwards, if the spire is in view and you start moving backwards, you're going to stop seeing that. The light coming from it will lift up and you're going to have to go further up in order to see the spire. So how can somebody that has moved back 150 miles, it would have to be a flying ship. So this is impossible on any Earth, and you have three options. One, you're navigating a flying ship. Two, it's a mirage, which is possible. Mirages happen all the time. And three is just lies. Yeah, as we've seen from the beginning, the Notre Dame Antwerp Spire has nothing to do with Strasbourg and is not 460 feet above sea level, but only 4 meters. Yes, and flat earth theory is full of these inconsistencies. I've seen them everywhere.